All right, let's dive in. Today, we're going to crack the code on how to write a perfect exam answer in chemistry. Seriously, no more guesswork, no more just hoping for the best. We're going straight to the source to see what a top-scoring answer actually looks like.
You know that feeling, right? You're staring at an exam paper, you know the chemistry, but you're just not sure how to turn that knowledge into maximum marks. Well, that's exactly what we're going to tackle today, using this real GCSE paper as our guide.
So, what's the big secret to unlocking top marks? Well, it's not really a secret at all. It's the mark scheme. This thing right here is the official blueprint the examiners use. If we can understand this, we can learn to think like they do and give them exactly what they're looking for. Let's get started.
Okay, first up, we're looking at a super common type of question, designing a method. You know, the how-to questions. These are all about testing if you can think like a scientist and plan a really logical, solid experiment. So here is our challenge, pulled straight from the paper. How would you set up an experiment to figure out where an unknown metal fits in the reactivity series? You know, that league table of how metals react. Before you start scribbling down ideas, let's see what the perfect method looks like, according to the people who do the marking.
And look at this. It's actually way simpler than you might think. The mark scheme boils it down to just 3 steps. 1. Add the metal to a solution. 2. Measure some kind of change. Temperature is a great one. And 3. Put the metals in order based on that change. That's it. A clear, logical process that gets you all the marks.
But hold on, a good procedure is only half the battle. To really nail this, you have to show you've made it a fair test by talking about your control variables. As you can see, that means things like using the same volume of solution, the same concentration, and the same amount of metal every single time. It's this level of detail that takes an answer from just good to great.
Okay, let's switch gears. We've done the how, now let's dig into the why. These next questions are all about checking your understanding of the fundamental rules of chemistry. It's not enough to know what happens. You've got to explain the science behind it.
And you guessed it, we're going right back to the source. This is the actual mark scheme for a question about reactivity. And as you can see, the perfect answer isn't just one fact, it's a really specific chain of logic. So let's break that down piece by piece.
So why is chlorine more reactive than iodine? Well, the perfect answer connects the dots. It starts with chlorine having fewer electron shells. That means its outer electrons are closer to the nucleus. Because they're closer, there's less shielding from the inner electrons blocking that positive pull from the nucleus. And the result? A much stronger attraction that lets chlorine snatch an electron way more easily. See how each point just flows into the next? That's what they're looking for.
Ready for another why question? Why does hydrogen chloride have such a low boiling point? Again, the answer isn't just a single fact. It's a 3-part argument, and we're going to walk through it step by step.
Okay, the very first link in the chain is to identify the structure. You get a mark just for pointing out that hydrogen chloride is made of simple, small molecules. It might sound basic, but it's the foundation for the whole explanation.
Now for the key detail, and this is where people can trip up. You have to mention the forces between the molecules, those intermolecular forces. A common mistake is to talk about the strong bonds inside the molecule, but the marks are for specifying that the forces between them are weak. That precision is everything.
And here's the final piece of the puzzle that ties it all together. Because those intermolecular forces are so weak, it takes very little energy to break them apart and get the liquid to boil. So you've got simple molecules, weak forces, and a low energy requirement. 1, 2, 3. That's your full marks answer right there.
All right, for our final section, let's talk about the numbers. We're diving into the calculation questions. This is where you have to prove not just that you know the answer, but that you know exactly how you got there.
I mean, look at this. It's printed right there on the exam paper. This isn't just a friendly suggestion, it's a command. Showing your work is completely non-negotiable. And for a good reason. Even if you mess up the final number, a clear, correct method can still earn you most of the marks.
So let's take a look at this bond energy calculation. The mark scheme shows that the very first step is to correctly figure out the energy for all the bonds you're breaking and all the bonds you're making. Just setting it out clearly like this gets you on the right track immediately.
The next crucial step is just putting it all together in the core equation. The overall energy change, which they gave us in the question, minus 51, is equal to the energy of the bonds broken minus the energy of the bonds formed. Laying out your calculation exactly like this makes it dead simple for the examiner to follow your logic and give you the points.
Then, after a little bit of rearranging to solve for x, you get your final answer, 290 kilojoules per mole. You see? Clear working, a correct setup, and the final answer. That's how you get full marks every time.
So after going through these 3 different types of questions, what have we really learned here? It seems to me it all comes down to learning how to think like a chemist and how to communicate like one too.
So here's your blueprint for success. When you're asked to design something, always lock down your controls for a fair test. When you're asked to explain something, build it like a story, with clear, logical steps. And when you have to calculate, show every single stage of your work. That's the winning formula.
So remember, acing a chemistry exam isn't magic. It's about understanding the logic, the blueprint that examiners are working from. You have that now. The only question left is, how are you going to build your next answer?